Good afternoon. Now we can discuss a new topic. So this is the last topic, that is DMA controller. Okay, we can discuss what is a DMA controller and its architecture and different registers available, internal registers available in a DMA controller. Okay, so 8257. That is the DMA controller IC. 8257. That is a DMA controller IC. Before discussing about DMA controller and all, first we should know what is a DMA. DMA means it is direct memory access. That means without the involvement of the processor, an external device can access the internal memory through bus. Okay, so that is what DMA means. Without the involvement of the CPU, external device can access the memory. Okay, that is DMA. And in order to control these operations, we will use an IC. That IC we will call it as the DMA controller 8257. 8257. Okay. DMA or direct memory access controller. It is an external device, okay, that control the transfer of data between the IO device. That means the external device and the memory without the involvement of the processor. Okay, so it holds the ability to directly access the main memory for read or write operations. So this is what a DMA controller. Okay. DMA controller is an external device. It is an IC which is used to transfer data between an external device and the memory. That means an IO device and the memory without the involvement of a processor. Okay, without the involvement of processor. That is what the DMA controller. Okay. Now we can see how these operations are performed. Okay. Uh, so how the DMA controller will perform its operations. That is it. That is what the sequence of operations performed in a DMA controller. Suppose an external device wants to access the memory. Okay, memory. So what it will do is it will just send a request. Initially, it will send a request. That means I need to access the memory. Okay, that is what called the DMA request. Okay, actually, first the external device will send that request to the DMA controller. Okay, that request we will call it as a DMA request, or sometimes we will call it as DRQ. Okay, DRQ. DMA request. That is, initially, when any device has to send the data between the device and the memory, the device has to send a DMA request to the DMA controller. That is the first step. That is the first step. That means first an external device has to send a request to the DMA controller. Okay. Then DMA controller will receive that request and it send a hold request. Okay, hold request to the CPU to release the bus. Then only it can transfer the data. Okay, so it will send a hold request, that is HRQ. We will call it as HRQ. So the DMA controller will send a hold request to the CPU and wait for the CPU response. Okay, that is DMA controller will wait for the hold acknowledgement signal. Okay, that is initially what suppose an external device wants to access the memory. So for that, first it has to contact to the DMA controller through a DMA request. Okay, through a DMA request. Then, if the DMA controller received the DMA request, then it will send a hold request to the processor. Okay, it will send a hold request to the processor and it will wait for the acknowledgement from the CPU. Okay, then when the hold request, when a CPU receive the hold request, then what the microprocessor will do is that it will try state all the data bus, address bus, and control bus. Okay, different buses are there. We already studied the architecture of this microprocessor and all. Three buses are there: data bus, address bus, and control bus. Okay, so the microprocessor will try state all the data bus, address bus, and control bus. Then what it will do is the microprocessor will send a control. That means microprocessor will send the acknowledgement signal with the control of the bus to the where DMA control. Okay. Then what that DMA controller has to manage. Then after receiving the bus control from the CFU, then DMA controller can manage the transfer of data between the external device and the CPU without the involvement. Sorry, between the external device and the memory without the involvement of CPU. So this is how a DMA controller performs operation. Okay, that means what are the procedure? First, suppose an external device wants to access the memory. So in that case, first the external device has to forward a DMA request to the DMA controller. Okay, after receiving that DMA request from the external device, the DMA controller will send a hold signal. Okay, DMA controller will send a hold signal to the CPU. Okay, then it waits for the acknowledgement. When the CPU received, that means the CPU means our microprocessor. Okay, when the microprocessor received a hold signal from the DMA controller, then the microprocessor will try state all the data buses. Okay, not only the data bus, address bus, and the control bus. Okay, it will try state all the data bus, address bus, and control bus. Then the CPU leave the control over bus. Okay, and acknowledge a hold request through a hold acknowledgement signal to the DMA controller. Okay, now the CPU is in hold state and DMA controller has to manage the operation over bus between the CPU, memory, and IO device. So DMA controller can manage the data transfer between the external device and the memory. Okay, so this is how the DMA, that means 8257 DMA controller perform its operation. So this is the sequence of steps for accessing the memory through this DMA controller. Okay. Then next we can discuss the different features of this 8257 IC. Okay. What are the different features? Okay. Here 8257, as I said, that it is an IC. In this IC, it has 4 channels are there. These channels are used for our IO device to transfer the data between the IO device and the memory. Okay, so in DMA controller 8257 has 4 channel. Okay, it is a 4 channel DMA controller. Okay, 8257 is a 4 channel DMA controller. That is why it has 4 channel and that can be used over 4 IO device. That means 4 IO device can connect these DMA controller together because it has 4 IO channels are there. Okay, so for external IO device can connect it with our DMA controller. Okay, and also each channel, as I said that there are 4 channels are there in DMA controller 8257. Each channel has 16-bit address line. Okay, each channel is having 16-bit address and 40-bit counter. Okay, 14-bit counter. So it has 4 channel and each channel is having 16-bit address and 14-bit counter. So each channel can transfer data up to 64 kilobytes. Okay, each channel can transfer the data up to 64 kilobytes. And one more important thing is that each channel can be programmed independently. Okay, all these 4 channels can programmed independently. It can work independently. Okay, so it has 4 channel. Each channel is having 16-bit address and 14-bit counter, and each channel can transfer the data maximum up to 64 kilobytes, and each channel can be programmed independently. Each channel can program independently. And also each channel can perform the read, write, what are the operations. Okay, verify operations. All these operations independently it can perform read and write and verify transfer operation. Okay, and also in DMA controller 8257, it operates in 2 modes. We can see what are the different modes in detail. So just remember this name. Okay, so it will operate in 2 mode. One we will call it as master mode, and the next one it is called as slave mode. Okay, it operates in 2 modes, master mode and slave mode. Okay, so 2 modes of operations are there in 8257. So these are the features of 8257 IC. Okay, what are the features? It has 4 channel that can be used over for IO device, and also what each channel has 16-bit address and a 40-bit counter, and also each channel can transfer data up to 64 kilobytes, and also it can be programmed independently. Okay, and also it can transfer it can perform read transfer, write transfer, and verify transfer operation. Okay, we can see how these operations will be performed in our ADMA controller and all. Okay, and also it will operate in 2 modes. One is master mode and next one is slave mode. Okay, it will operate in 2 modes, master mode and slave mode. Okay, so this is the feature. Okay, these are the features of 8257. Okay, so it is an IC which is used to transfer the data between the external device and the memory without the involvement of CPU. So this DMA controller will manage all this data transfer. Okay, now we can discuss the architecture of this 8257 IC. Okay, 8257 IC. So this is the architecture diagram of 8257 IC. Okay, here you can see that different blocks. Okay, or sometimes it will call, sometimes question may ask like this, draw the block diagram of 8257 IC. Okay, whatever it is, okay, everything is same. Internal architecture of 8257. Okay, so as I said that it is having 4 channels are there. So these are the 4 channels. That is channel 0, channel 1, channel 2, and channel 3. Okay, so these are the 4 channels. Okay, these channels are connected to the external IO device. Okay, channel 0 can connect to one external IO device. Channel 1 can also connect an external IO device, another. So likewise, 4 IO device can connect this DMA controller. Okay, so as I said that for requesting a DMA operation, first it has to send a DMA request. So for accessing the channel 0, the external device will send a DMA request 0 to the channel 0. Then after receiving this DMA request, okay, what the DMA controller will do? DMA controller will send a hold signal to the processor. Okay, processor will be here. Then from the processor, it will get an acknowledgement. So then DMA controller will forward a acknowledgement to the external device that the bus is now available. You can transfer the data like that. Okay, so these are the two signals associated with this channel. One is DMA request, next one is DMA acknowledgement. Okay, so it is a 16-bit address and 14-bit counter. Okay, so channel 0, channel 1, channel 2, and channel 3. Here you can see lots of internal connections are there. So this we will call it as an internal bus of DMA controller. Okay, then next one priority resolver is the data bus buffer is the read write logic is the control and the mode set logic is the. As I said that it can operate in two modes. One is master mode and the next one is slave mode. It can operate based on the value of the address line. Okay, we can see how it will perform the operations in master mode and how it will perform the operations in slave mode. Okay, we can see that how it will perform this operation. So uh, these are the different channels. Okay, channel 0, channel 1, 2, and 3 that are connected to the external device. Then next we can see one bus buffer is the data bus buffer. So this is the data bus buffer. Okay. Actually, it is an 8-bit tri-state buffer. Okay. It is a bi-directional buffer. Both the data can send and receive the data through this buffer. Okay. So it is a bi-directional buffer. Okay. So it is connected to the internal bus of the 8257 IC and to the external system. Okay. So through this data bus buffer, the data will be transferred. So it is an 8-bit buffer, 8-bit tri-state buffer, and it is also a bi-directional buffer. As we know that data buffer is itself is a bi-directional. Data can send and receive the data through this buffer. Okay. So this is the data bus buffer. Then next block is so based on the value of this IOR and IOW, that means read and write signal, then based on the value only it will operate the bus. That means whether it is a read operation or whether it is a write operation, whatever it is. Okay. So based on the value that is received from this read write logic, it will operate. Okay. So here this is the next block. You can see it is a read write logic. Okay. Read write logic. So read write logic, you can see different signals are associated with this read write logic. And as in the introduction itself, we studied that it can operate in two modes. One is what we will call it as one is master mode. Okay, master mode, and the next one is slave mode. Okay, so it will operate two mode, master mode and slave mode. Two modes of operations ഉണ്ട്. രണ്ട് മോഡിലാണ് അത് ഓപ്പറേറ്റ് ചെയ്യാന്ന് പറഞ്ഞത് അല്ലെ, മാസ്റ്റർ മോഡിലും സ്ലേവ് മോഡിലുമാണ് അത് ഓപ്പറേറ്റ് ചെയ്യാന്ന് പറഞ്ഞത്. ഓക്കെ, ദെൻ റീഡ് റൈറ്റ് ലോജിക്കിന്റെ കേസിൽ in slave mode it acts as an input. Okay, and in master mode it acts as an output. We can see how it will act as an input and how it will act as an output. Okay, so this is the block. Okay, so in master mode what it will do is, in 8057 IC, actually this IC is having almost 10 internal registers are there. We can discuss that. What are all the different registers? Okay. But you just understand that it's this IC is having 10 internal registers. Okay. So in slave mode, it receive this read write logic will receive these IO read and IO write signal. Okay, so in slave mode it will receive these two signal, IO read and IO read, write signal, and you can see four address bus are here. You can see A0, A1, A2 and A3. Okay, so it will decode these address line. This read write logic will decode these address line. Actually, what is the use of this address line is that, okay, as I said that there are 10 internal registers are there. Okay, so to select those particular register, you this read write logic will use these address buses. Okay, so by decoding these A0 to A3, these four address line, it can identify which particular register it has to select. Okay, then after selecting that particular register, then based on the signal value of IOR and IOW, it will perform either a read operation or a write operation to that register. Okay, so this is what the read write logic of block perform its operation in slave mode. Okay, what is the operation it is performing? In slave mode, as I said that it acts as an input. It acts as an input. Okay, that means it accepts IO, that means read and write control signal. It accepts read and write control signal. Then also it decode these address line. Okay, it decode these address line, but after decoding this address line, it will get a particular register, because it is having almost 10 internal registers are there in 8257 IC. Okay, so after decoding this A0 to A3, it will get a particular register. Then based on the value of that IOR and IOW signal, it will perform corresponding operation to that register. So that is why we will call it as in slave mode. This read write logic will act as an input. Input. Okay. Then next in master mode, we can see how it will perform. Okay, in master mode, actually it acts as an output. Okay, in master mode, it acts as an output. That means based on the value of read write logic, and so it will what it will control the data flow from the selected output. That means selected peripheral. Okay, so it will select a particular peripheral in master mode, and it will control the data transfer between that peripheral and the 8257 controller. So that is why we will call it as a output. Okay, so in my master mode, it acts as an output. Okay, that means read write logic IOR and IOW signal to control the data flow to between the selected peripheral and the controller. Okay, so this is what the read write logic. Okay, read write logic. Important ആണ് read write logic. അപ്പോൾ read write logic ഇൻപുട്ട് ആയിട്ടാണ് സ്ലേവ് മോഡിൽ ആക്ട് ചെയ്യുന്നത്. ഇൻപുട്ട് ആകുമ്പോൾ based on the value from IOR and IOW, A0 മുതൽ A3 വരെയുള്ളൊരു പിന്നെ യൂസ് ചെയ്തിട്ട് it will select a particular register, എന്നിട്ട് ആ രജിസ്റ്ററുമായിട്ടുള്ള ഡാറ്റ ട്രാൻസ്ഫർ ആണ് നടക്കുക. ഇനി മാസ്റ്റർ മോഡിലാണെങ്കിൽ എന്താണ്? മാസ്റ്റർ മോഡിലാണെങ്കിൽ okay, based on this value, ഈ സിഗ്നലിന്റെ വാല്യൂ വെച്ചിട്ട് തന്നെയാണ് ഓപ്പറേഷൻ നടക്കുക, whether it has to perform read operation or write operation, but it is in between the external device and the controller. Okay, so for selecting this chip, this 8257 chip, there is a signal called CS bar. Okay, it is an active low signal used to select the chip. That means 8257 enable ചെയ്ത് active ചെയ്തിട്ട് വർക്ക് ചെയ്യണമെന്നുണ്ടെങ്കിൽ you need to apply an active low signal to this CS bar IC. Then only it will be active. Okay. So this is what the read-write logic of 8257. Okay. So these are the pin associated with this 8257 IC. IOR, IOW, read and write. Okay. Then this is clock pulse and this is reset. That you already know that for providing the clock input, this is a clock for performing reset operations. Here you can provide the signal, reset signal and all. Okay. Then for selecting a particular register, you can use this. Then this is for selecting the IC, enabling the IC for performing its operations. Okay. Next, another block you can see. That is what the control logic. Okay. Control and mode set logic. Okay. Control and mode set logic. Actually, the main duty of this control and mode set logic is that it controls the sequence of operations that is performed in this controller. Okay, it controls the sequence of operations. Not only controlling the sequence of operation, but also it will generate some control signals. Okay, so these are the two main operations that is performed in this control and mode set logic. Okay, control and mode set logic. That means it controls the sequence of operation and also it generates the control signal. Okay. Now we can see what are the signals it will generate. Okay. So here you can see one signal. It is HRQ. As while discussing that, we know that what is HRQ? It is a hold request signal. Or hold request signal generate to request the CPU to get the system bus. To get the system bus. System bus കിട്ടിയാലേ എന്ത് ചെയ്യാൻ പറ്റൂ external device data memory transfer ചെയ്യാൻ പറ്റും. So for getting that system bus, the control and mode set logic will generate a hold request. So this is what the hold request. അപ്പോൾ ഒരു സിഗ്നൽ ജനറേറ്റ് ചെയ്യുന്ന എന്താണെന്ന് മനസ്സിലായി hold request ആണ്. Okay. Then our request കൊടുത്തു കഴിഞ്ഞാൽ നമുക്ക് എന്ത് കിട്ടും from the processor it will receive a hold acknowledgement signal. That is what it is here. So the signal receive ചെയ്യുന്നതാണ് from processor. അല്ലേ? If bus is available, then processor will send a hold acknowledgement. So it can receive this hold acknowledgement signal. Okay. Then another signal it is generated from this control and the mode set logic is memory write signal. Sorry, memory read signal to read the data from the memory, and also another control signal is memory write. So that is used for write the content to the memory. Okay. Then one more signal is that is AEN, which is used to actually this AEN we already studied that AEN. Okay, that means used to disable or enable the address or data bus. Okay, so that is AEN pin. Then ADSTB signal. Okay, ADSTB signal. Actually, ഇതെന്തിനാണ് യൂസ് ചെയ്യുന്നത് വെച്ച് കഴിഞ്ഞാൽ it is used to convert the higher order byte of memory address that is generated by the DMA controller to latches. Okay, അതിനു വേണ്ടിയിട്ടാണ് ADSTB എന്ന് പറയുന്ന സിഗ്നൽ ജനറേറ്റ് ചെയ്യുന്നത്. ഓക്കെ, ദെൻ ഒരു TC എന്ന് പറയുന്ന സിഗ്നൽ ഉണ്ട്. ഇറ്റ് വിൽ കോൾഡ് ആസ് ടെർമിനൽ കൗണ്ട് എന്ന് പറയും. ഓക്കെ, ടെർമിനൽ കൗണ്ട്. ടെർമിനൽ കൗണ്ട് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ദാറ്റ് ഇൻഡിക്കേറ്റ് ദ പ്രസന്റ്. ദാറ്റ് മീൻസ് ആ ടെർമിനൽ കൗണ്ട് എന്താണ് ഇൻഡിക്കേറ്റ് ചെയ്യുന്നത് വെച്ച് കഴിഞ്ഞാൽ ഇറ്റ് വിൽ ഇൻഡിക്കേറ്റ് ദ പ്രസന്റ് DMA സൈക്കിൾ. ഇപ്പോഴുള്ള DMA സൈക്കിളിനെ ഇൻഡിക്കേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് യൂസ് ചെയ്യുന്നതാണ് ദിസ് സിഗ്നൽ, ടെർമിനൽ കൗണ്ട്. ദെൻ മാർക്ക് സിഗ്നൽ ഈസ് ദർ. ആക്ച്വലി മാർക്ക് സിഗ്നൽ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മുടെ DMAയുടെ ഓപ്പറേഷൻസിന്റെ ഓരോ സൈക്കിൾ ഉണ്ടാവും. ഓക്കെ, അപ്പോൾ ഒരു 128 സൈക്കിൾ ആയി കഴിഞ്ഞു കഴിഞ്ഞാൽ ഈ മാർക്ക് സിഗ്നൽ ആക്റ്റീവ് ആവും. ഓക്കെ, അപ്പോൾ ഈ മാർഗ സിഗ്നൽ എപ്പോഴൊക്കെ ആക്റ്റീവ് ആയിട്ടുണ്ട് എങ്കിൽ നമുക്ക് മനസ്സിലാക്കാൻ എന്താണ്, നമ്മുടെ കറണ്ട് ഡി എം എ സൈക്കിൾ ഈസ് 128 സൈക്കിൾ ആണെന്ന് മനസ്സിലാക്കാം. ഓക്കെ, അതിനു വേണ്ടിയിട്ടാണ് നമുക്കത് ഓപ്പറേഷൻ്റെ പഠിക്കുമ്പോൾ ഡീറ്റെയിൽ ആയിട്ട് അതിനെ കുറിച്ച് പഠിക്കാം. ഓക്കെ, അതിനു വേണ്ടിയിട്ടാണ് ഈ മാർഗ് സിഗ്നൽ യൂസ് ചെയ്യുന്നത്. ഓക്കെ, ദെൻ ആയോ എല്ലാം? ഇല്ല, ഹിയർ 4 address lines are also there. 4 address line ഉണ്ട്. Actually these address line these are the higher nibbles ആണ് അല്ലെ, A4, A6, A5, A4. Okay, so these are the higher nibbles of the lower byte address generated by the DMA in master mode. Master mode ജനറേറ്റ് ചെയ്ത അഡ്രസ്സിന്റെ ലോവർ ബൈറ്റിലുള്ള ഹയർ ഓർഡർ ബിറ്റ്സുകൾ നിബിൾസുകളാണ് നമ്മുടെ ഈ A7 to A4 അല്ല A4 to A7 എന്ന് പറയുന്നത്. ഓക്കെ, അപ്പൊ ഇതാണ് നമ്മുടെ കൺട്രോൾ ആൻഡ് മോഡ് സെറ്റ് ലോജിക്. ഓക്കെ, അപ്പൊ ഇതിൽ ഓർത്ത് വെക്കേണ്ട എന്താണ്, കൺട്രോൾ ആൻഡ് മോഡ് സെറ്റ് ലോജിക്. ഓക്കെ, ഇറ്റ് കൺട്രോൾ ദ സീക്വൻസ് ഓഫ് ഓപ്പറേഷൻ ആൻഡ് ഓൾസോ ഇറ്റ് ജനറേറ്റ് ദ കൺട്രോൾ സിഗ്നൽ. ഓക്കെ, ആൻഡ് നമ്മൾ അതിന്റെ ഡിഫറെന്റ് അസോസിയേറ്റ് ചെയ്തിരിക്കുന്ന സിഗ്നൽസും കൂടെ പഠിക്കണം. ഏതൊക്കെ സിഗ്നൽസ് ആണ് ജനറേറ്റ് ചെയ്യുന്നത്, അതുപോലെ തന്നെ ഏതൊക്കെ സിഗ്നൽ ആണ് റിസീവ് ചെയ്യുന്നത്. ഓക്കെ, സോ ദാറ്റ് ഈസ് കൺട്രോൾ ആൻഡ് മോഡ് സെറ്റ് ലോജിക്. ദെൻ one more block is here. You can see it is priority resolver. Okay, എന്താണ് priority resolver എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നെയിം ഇറ്റ്സെൽഫ്, നെയിം തന്നെയുണ്ട് അല്ലെ. എന്താണ്, ഇവിടെ നമ്മുടെ 4 ചാനൽസ് ഉണ്ട്. Okay, CH0, CH1, CH2, CH3. Okay, so this priority resolver will resolve these priority of these 4 channels depending on whether it is normal priority or rotating priority, whatever it is. Okay, so this priority resolver is used to resolve the priority in these different channels. Okay, so these are the different blocks present in a 8257 IC. Okay, അപ്പോൾ ഇതാണ് ഡിഫറെന്റ് ബ്ലോക്സുകൾ. ക്ലിയർ ആണോ? ആർക്കിടെക്ചറുകൾ സിമ്പിൾ ആണ്. ഈ ബ്ലോക്ക് പറയാ, അത് എക്സ്പ്ലെയിൻ ചെയ്യുക അല്ലേ. ഓർത്ത് വെക്കേണ്ട പോയിന്റ്സ് ഇത്രയാണ്. ഇറ്റ് ഈസ് ഹാവിങ് 4 ചാനൽസ് ഉണ്ടാവും. ഓരോ ചാനലും അസോസിയേറ്റഡ് 2 സിഗ്നൽസ് ആണുള്ളത്. ഒന്ന് DMA റിക്വസ്റ്റും പിന്നെ ഒരെണ്ണം DMA അക്നോളജ്മെന്റ്. ഓരോ ചാനലും 16 ബിറ്റ് അഡ്രസ് ആണ്. ഓക്കെ, CH0, CH1, CH2, CH3. ഓക്കെ, അതാണ് നമ്മുടെ DMA ചാനൽ. ഇവിടെയാണ് നമ്മുടെ എക്സ്റ്റേണൽ ഡിവൈസുകൾ കണക്ട് ചെയ്യുക. 4x IO device can connect. Then data bus buffer is there. It is a tri-state buffer, 8-bit buffer, bidirectional. Okay, internal നമ്മുടെ കൺട്രോളറിന്റെ ഇന്റേണലും അതുപോലത്തെ സിസ്റ്റത്തിന്റെ എക്സ്റ്റേണൽ സിസ്റ്റം ബസ്സുമായിട്ട് കണക്ട് ചെയ്യാം. ദെൻ റീഡ് റൈറ്റ് ലോജിക് രണ്ട് രീതിയിൽ നമ്മൾ വർക്ക് ചെയ്യുന്ന പറഞ്ഞ് മാസ്റ്റർ മോഡ് ആൻഡ് സ്ലേവ് മോഡ്. ദെൻ അതിന് അസോസിയേറ്റ് ചെയ്തിരിക്കുന്ന സിഗ്നൽസ്, ദെൻ കൺട്രോൾ ആൻഡ് മോഡ് സെറ്റ് ലോജിക്, അത് ഓർത്ത് വെക്കുക. അതിന് അസോസിയേറ്റ് ചെയ്തിരിക്കുന്ന സിഗ്നൽസ്. ദെൻ ലാസ്റ്റ് ബ്ലോക്ക് ആണ് പ്രയോറിറ്റി റിസോൾവർ, used to resolve the priority in these different channels. Okay, so that is the architecture of our 8257 IC. Okay, so this is the architecture. ക്ലിയർ ആണോ? എന്താണ് അപ്പോൾ DMA കൺട്രോളർ? ഒരാൾ പറഞ്ഞേ, വാട്ട് ഈസ് DMA കൺട്രോളർ? അമൽ, വാട്ട് ഈസ് DMA കൺട്രോളർ? എന്തൊക്കെയാണ് അതിന്റെ ഫീച്ചേഴ്സുകൾ? അമൽ രവീന്ദ്രൻ, അമൽ രവീന്ദ്രൻ, ആർ യു പ്രസന്റ്? പ്രസന്റ് ആണോ? അമൽ രവീന്ദ്രൻ ആബ്സെന്റ് ആണോ? റെസ്പോൺസ് ഒന്നും കാണുന്നില്ലല്ലോ. എന്താ നന്ദിത DMA കൺട്രോളർ നമ്മൾ എത്ര സമയം ഡിസ്കസ് ചെയ്തത്? നന്ദിത പി പറയാൻ പറ്റുമോ? നന്ദിത പി റെസ്പോണ്ട് ഒന്നും ചെയ്യുന്നില്ല അല്ലെ? നന്ദിതയും അമൽ രവീന്ദ്രനും ആബ്സെന്റ് ആണോ? ഓക്കെ, നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ആശിഷ്, അഭിനവ്, അഭിഷേക്, ആദിത്യ, ഐശ്വര്യ, അഖിൽ, അഖിൽ CV, അഖിൽ K, അമൽ സുരേന്ദ്രൻ, ആമിന, അനൈന, അനിരുദ്ധ്, അഞ്ജിത, അനൂജ, അനുപമ, ആരോമൽ, അർപ്പിത്, അരുൺദത്ത്, അശ്വിൻ, ഫസ്ന, റംഷാദ, ഹൃദുൽ, ജെറീഷ്, ഖദീജ, ലിഖിത്, ലിയാന, മിഥുൻ, നാസിഫ്, റാസി, മിനാജ്, നിഹാൽ, സാലിഹ്, ഷഫീഖ്, നബീൽ, നന്ദ, നന്ദിത, നിവേദ്യ, പ്രിൻസ്, നൂഹ, ഋഷികേശ്, റിസ്വിൻ, ഋത്തിക്, രോഹിത്, സഫീൽ, സങ്കീർത്തന, സാരംഗ്, സേജ്, ഷബിൻ, സെവിൻ, ശിഷാജ്, തനുശ്രീ, തേജ, തുളസി, വൈഷ്ണവി, വിഷ്ണു, വൈഷ്ണ, യാദവ്, അമൽ, അമൽ രവീന്ദ്രൻ. പ്രസന്റ് ആണോ അമൽ രവീന്ദ്രൻ? നേരത്തെ ഞാൻ ചോദിച്ചപ്പോ റെസ്പോണ്ട് ഒന്നും കണ്ടില്ലല്ലോ. ഓക്കെ, അപ്പോൾ നമുക്ക് അടുത്ത ക്ലാസ്